Ever wonder how scientists organize the entire building of universe into one single chunk? Today we are discovering the periodic table of elements made by Dmitry Mendeleev and Lothar Meyer in 1869. We organize it into 8 new vertical groups and 7 horizontal periods. But how do we know where each element lives? It all follows the Aufbau principle, where subshells are filled with electrons in order of increasing energy levels. And the real secret is in the blocks S, P, D, and F, which based on where their last electron lands. If they are in the same columns, same number of valence electrons.
Have you ever wondered what does the staircase shape means in the periodic table? Well, it means as element classification.
Okay, from the very left side is metal, and then the staircase shape is represented by metalloid, and then to the very right is non-metal.
First up, appearance. Metals are shiny, malleable, and usually solid, except for mercury is in liquid. Non-metals, they are the opposites, dull, often invisible gases. They are so brittle and shatter if heat. Metalloids, they are in the middle ground. They look like metal but crack like glass.
Now, let's talk energy. Metals are the ultimate superconductors of heat and electricity. Now, for nonmetals, they are the insulators. They block the flow from flowing. But metalloids, they are the gatekeepers. They only conduct under certain conditions, making them the perfect semiconductors for your phone.
Now let's understand how valence electrons influence the properties of elements, starting with metals in the left side of periodic table. But first, we have to know what valence electrons are. Valence electrons are the electrons in the outermost shell of an atom. For main group elements, the group number usually indicates the number of valence electrons. For example, group 1 elements like sodium have 1 valence electron, while group 17 elements like chlorine have 7 valence electrons. Now, looking at metals on the left side of a periodic table, they tend to lose electrons easily, forming positive ions. Their reactivity increases down the group because the outer electrons are farther from the nucleus and easier to remove.
Next, let's look at nonmetals and noble gases.
Nonmetals are located on the right side of the periodic table. They tend to gain electrons to form negative ions. Their reactivity increases up the group because smaller atoms attract electrons more strongly. For example, fluorine is more reactive than iodine. Noble gases in group 18 have a full valence shell, usually 8 electrons, except helium, which has 2. Thus, they are very stable and have very low reactivity. Finally, transition metals are different. Their valence electron configuration does not follow a regular pattern within a group, but they share many similar chemical properties that distinguish them from other elements.
Now that we have the table, what would happen if we go across the period and down the group?
Moving from left to right in the periodic table, the number of protons will increase while electrons are added to the same energy level. This causes the atomic radius to decrease because the stronger nuclear attraction pulls the electrons closer. At the same time, ionization energy and electronegativity increase, meaning atoms hold onto their electrons more tightly. On the other hand, when we go down the group, new energy levels are added. This increases the distance between the nucleus and the outer electrons. Therefore, atomic radius increases, and because it is further away, ionization energy and electronegativity decreases.
The periodic table isn't just a chart, but it's a series of patterns. These strands, atomic size, electronegativity, and ionization energy all follow the same logic. It's just about how the nucleus pulls on its electrons. Once you see that, the whole table starts to make sense.
So, every trend in the periodic table comes down to one idea: how strongly the nucleus holds onto its outer electrons. Move across a period, and the nuclear charge increases. The electrons are pulled in closer, so the atom shrinks. Ionization energy and electronegativity both rise. Move down a group, and new energy levels are added. The outer electrons get farther away and the nuclear grip weakens. The atom grows larger, whereas ionization energy and electronegativity both fall. Two directions, opposite results, but the same logic driving it all. Once you see it that way, the periodic table isn't something you memorize, it's something you understand.